Shut up and sit down.
Hello everyone, welcome to my latest live coding stream. I am Kitecraft and we are coding live for HardSenseESP. Let me make you all big here. So, if you're new to the stream, if you're new to the live coding and you haven't seen any of the previous streams, what I'm working on is a HardSense is a two-part project. First of all, there is a Windows program called HardSense64. I know I just had this set up. Where'd it go? There it is. There's two parts to the HardSense project. There's the Windows project, which is the boring part. This is it. This monitors a whole bunch of sensors inside the computer, like GPU temperatures and speeds, CPU temperatures and power usages, fan speeds, FPS counters, network speeds. It just sets up a monitor for all of that and then sets up a TCP server that clients can connect to. And I call this HardSense64. But the interesting part that we're working with today is this over here. It's called HardSenseESP. This here is an ESP32 microcontroller, and it's connected to a 2.8 inch, this over here, a 2.8 inch TFT LCD display with touchscreen. We can get a much better look at actually what's happening here. The microcontroller's only about that big. In comparison, let me show you something here. Let me turn that. See, can you see what's going on there? This is called an Arduino Uno. More commonly known as nowadays as an Arduino Uno, I think. So this was over $20, and I think the Arduinos nowadays are still over about $20. This is one of these is about a 16 megahertz single-threaded CPU, and it can do a lot of really neat things with the USB connected to it, and a whole bunch of pins for both digital and analog, and it's really, really cool. And this is where pretty much all of us actually got of our start, is always you're dealing with some sort of an Arduino. Most recently, though, there is enough of a variety out there that some people may not have ever actually have used an Arduino itself, not even an Arduino Uno, or maybe not even a clone of an Arduino Uno. They've gone straight into other things, because there are, in fact, other things. And this is one of them. This is what I'm using today. This is called an Arduino, or an ESP32S. It's going to have all sorts of names. If you look on the chip, it says ESP32 WROOM. It's also known as a Node MCU 32S, or perhaps the DevKit C, which I think is the version that we see over here. There's a whole bunch of different ones, but you know what? They're just call it the ESP32S, and we're going to be happy. I'm not using any weird pins. I'm not using any of the DACs or anything like that. So just an SPI and a couple of buttons. But what's really going on here is that we're actually displaying real-time sensor information from my computer. CPU loads, temperatures, wattage and power. This is the video card usages, hard drive, amount of used space on the hard drives, the date and time. My network speeds. The reason why we see such a high download speed is because I have several IP cameras connected to my computer. So the view that you're seeing right now is an IP camera, and it's connected to this thing right here, which is actually recording this view down here. That's an IP camera. And then, of course, there's a few other things going on. Now, let's get the zoom back on here, or the focus back. There we go. Perfect. The RAM panel you see on this home screen is, in fact, my system RAM, which I think is 32 gigabytes, supposedly, and you can see it's using about 9. Now, the neat thing about this is it is, in fact, a touchscreen. So, you can see where the screen is. It's about this big. Let me hold up another one for you. It's right here. if you're new to these, this is how big they are. Not very big at all, 2.8 inch, but they're beautiful and they look good. And I cannot record it well enough with these video cameras to do it justice. But if we just touch on the GPU panel, we go to what's called my game screen. Yes, this is a fully functioning, responsive touch screen. When I'm not coding it wrong, it's doing the right thing. Anyways, well, I'm laughing about a bug I found in a previous stream. So this is the, let's have a closer look at what's going on here. This is my game screen. We have a 90-second graph for the fan and temperature. So when I'm playing the game, we're going to see these numbers go up. And they're important numbers to me, the CPU or the GPU temperatures. And then, of course, our clock speeds. The RAM panel you see here, this is all about the video card RAM, whereas the previous RAM panel on the home page was for my system. This is my game screen, so this is my video card RAM. And, of course, the video card load. The net panel is always useful in games. If you're, pardon me, playing any sort of online game, it's nice to know what the network speed is. And my FPS counter. We can actually go back to the home screen. All of the screens past the home screen have a home button. The bottom right corner is always going to be the home button or the back button, depending. It can be overridden, but it's there by default. We can go into the CPU screen just by touching on that, and we'll see this screen actually divides by core, not by processor. I think that's, or by thread. So what we're seeing here is actually a hex core CPU that's hyper-threaded. So in Task Manager, this would show up as 12 processors, but there's really only 6 cores to it. And what we're seeing is the individual core speeds, temperatures, and the load. This graph is a bit odd looking. It's kind of giving you a cluster view of the usage for that particular CPU, or for that particular core. It's just the highest resolution that you can get on this display, which is a, what is it? What the heck is it? 480 by 320? 320 by 260? It's a 320 by 260. Let's have a look. You know what? I totally forgot what it actually is. Let's go to Arduino here. If I go to File, Examples, scroll all the way down, there's TFT-ESPI. This is Bodmer's library. It's a 320 by 240. That's what it is, 320 by 240. The 480 by 320 happens to be this display right here. This is the higher resolution for 3.5 inch, which I'm going to be experimenting next with the same library and the same display manager. So this will be cool. So what we're working on, let me go back to the home screen. Last thing I want to show you, you may have noticed it, some of you may have been astute enough to see what's going on in this particular image, but over on the left side, let me get my pointing stick. Over on the left side here, hello, you see what's going on here? I have my toy oscilloscope. Right there. Right there. I have my toy oscilloscope hooked up, and it's being monitored by my toy paratrooper. Let's get a closer look at what's happening again. So the oscilloscope is actually hooked up onto this breadboard. Here is the negative line to the oscilloscope. The red line is this particular wire you'll see coming off. You can see they both kind of disappear onto the edge around here, through here, and then they go through this way, and then the cable comes up over here. So that's the line of the, and this red wire is actually connected to the CS line of the display. So these displays use an SPI interface between the microcontroller and the display. It's called SPI. So that has a couple of lines like MOSI, MISO, clock, and CS. which is your chip select. You know all about SPI. You go ahead and look up what it says. But that's what the oscilloscope is actually connected to. So what does this mean? What we're seeing on the scope is every one of those dips is when the microcontroller is asking the TFT is sending data to the TFT. The microcontroller will pull that CS switch low, apparently. That's what at least it looks like on the scope. It pulls it low, and then it sends the data to the screen for the update, and then the firmware on the microcontroller sends that to chip select back high to release it. So there's an interesting thing that we can prove about this. I'm going to go to a new screen called the Bluetooth Configurator screen. By holding the blue button down during startup, my program will kick into the Bluetooth Configurator screen. Now the only thing updating on this screen is this clock in the corner. There is no other data updating, and that clock updates once every second. So you can see on the oscilloscope over there, we just have a regular pulse that's the same width because it's drawing the same amount, the same number of pixels every single time. Once a second, we have a nice pulse on there. Now, if we reboot this back to the home screen also has this same clock on it. So you can see we actually have that same pulse happening on this home screen. That's that leading pulse in the oscilloscope. But you can also see there's a lot of other activities happening in the meantime. Now this display is actually updating in real time. It's not just updating all of the values like once every 20 seconds. As it gets a new value, the screen updates, and it has the capacity to update up to well, if things were running, it could probably update a total, actually that's not even a real number that I could say. You have to see what's happening on the oscilloscope. That gives you a much better idea of what's happening for the updates than any number I could give you. So what I'm working on now is one of the very final steps before I move on to the next phase. The next phase is building the circuit boards to so as you can see, we have the microcontroller and a bunch of wires here connecting to the display. We have a little button, and then down here we have this thing. This is called a real-time clock, or an RTC, and it's communicating back to the microcontroller using a different type of protocol called I2C. You can look that one up. But I need a circuit board that I can actually plug this into, or whatever. And then I have this over here. This is a rotary encoder. It can be turned, and it actually controls the volume. It's able to feed back. The microcontroller feeds back information to my computer, and it can turn the volume control up and down, which is actually really handy. So I need a circuit board to connect all that stuff to, and that's the next step. But before I can really get to and then the final step is, of course, to build the box, which will be about this big. You see my voltage transmogrifier box here. That's this box. We can get a good picture of it where my hand is. If you look in the bottom corner of your screen, you can see my hand on this panel, or this box. So the final box for HardSense will be approximately this size, not quite as wide, but a little taller, but that's approximately what it's going to look like. And that'll be the final step. But over the weekend, I really want to get into making the circuit board starting tomorrow. And the last thing I really need to do, code-wise, is to give it the ability to update the firmware without plugging in the USB cable. That's actually really important to me. You'll notice that the USB up here, this is in the final product, it's going to be inside a box. Right? It's going to be inside a box of some sort. Right? Here's a box. The final HardSense box will be something about this size. More like, it'll look like about that size, except angled. But whatever. I'm not going to have easy access to the USB port. Right? We have the microcontroller. It's going to be inside this box somewhere. I'm not going to have easy access to it. You want to have what's called OTA, or over-the-air updates. That way, this thing can be connected to the network, and new firmware can be uploaded to it without having to touch this. I want the final HardSense box to be fully wireless. It's going to actually run off a nice battery, a nice big LiPo battery, so it'll have a good long life. And it's going to be Wi-Fi as well as Bluetooth enabled. You see the Bluetooth configurator screen. So you're going to love that. Okay, you can go ahead and have a look at my GitHub page. I am Kitecraft, github.com/Kitecraft. I'm working on the project called HardSense. Now, when you first come into HardSense, you're going to see this. For today's episode, I'll be working in branch number 18, add OTA. I've already got some new changes in here. For example, specific new partition that we have to use to compile. And I've also got new font files. The new font files are actually smaller than what I was using, so I saved a lot of space on the SPIFFS file system. Ooh, another cool thing about the ESP32 microcontroller, it has a file system. That's how a lot of this stuff actually works. It's so cool. Okay. So this, you have to use this now. There's a new partition scheme when you're in the Arduino IDE or whatever your favorite editor is. I'm actually going to be using VS Code. It is not my favorite text code editor. It really isn't. No, it isn't. I prefer Visual Micro, but I'll complain about that. The first time I actually have to compile something in VS Code, I'll start complaining about VS Code vehemently and why I like Visual Micro. However, we can avoid that by having a look at the very bottom of this particular window that you see. You can see my development environment is right here. I'll go into that in a minute. I'm up here in the top corner. Hi, nice to see you. If you ever want to see me looking fiercely thoughtful, just have a look up at that top window. You'll see me in all my wondrous glory. Down below we have, of course, HardSense, so we can always see what it's doing. And if it crashes, let me know. I may not always be paying attention, but I know I've developed a bug in there over the last few days. I've actually been not paying attention to a lot of things with the streaming and writing code and learning all this stuff, and I think I've introduced a bug in there, and it is crashing, and I want to figure that out. And then down at the bottom of the screen is, of course, my little bugs. It would really help me out. I would like to use Visual Micro for my code development. It's a Visual Studio extension for doing IoT development, especially Arduino-based development. But it is so wonderful. It is so fast for compiling and updating to your software. Now, I'm no expert in anything. I don't get endorsed by anybody. This is all my entire own opinions about everything. I've learned everything myself. This is me just kind of being a beggar. Like I said, it's those, the PayPal me, Kitecraft, and Patreon accounts, which I'm still setting up. I'm going to be saying that because I don't really know what to do. Yeah, if you want to actually throw me a few bucks, I want to try and get a Visual Micro license, but it costs about $26 to $27 for a yearly license, and that's about $140 more than I can afford to spend. I want to get some better cameras to try and do some streaming with, so that everything isn't quite as horrible as it looks. I want to pay rent and eat some food. So there's some links down below if you want to help me out. Otherwise, we're going to actually jump right into what it is to be on the GitHub page, like I was saying. Oh yeah, that's what kicked off this particular rant about Visual Micro. The partition. We go to Tools. You can see there's a new partition scheme called HardSenseESP partition. This is what I need to use now to do all the building with the application, and now it's going to make life a lot easier for me having that there. And to set all that up, if we just go into Software, ESP32, I've updated the README. Here you can see that there's the CSV file, and I've updated the README about how to install that so that it shows up in that menu system. If you actually want to do it, just do what's written in that README file. It'll get you there. Or you can read watch the end of the last stream. I think the last half hour of the stream is where I actually did all of this. And there's new fonts. These new fonts are significantly smaller. I just got rid of a lot of the, so these fonts actually had a lot of character sets in them. And I just wasn't using any of those extended character sets. Well, there's 2 extended character sets. I actually only needed one of them because HardSense ESP, it displays a few special characters, like the %C and the degrees C and the % symbol. They actually weren't in the really small package. So what I did was I made new font packages that are actually smaller. This allows us to use a smaller SPIFFS file system. Now, this whole partition is actually just a copy. If you don't want to do all this HardSense ESP partition, if you don't want to set it all up, that's fine. Use this one right here. It's called Minimal SPIFFS. 1.9 megabyte app with it's the same partition. I'm just keeping this. I just wanted to have my own named partition, and I wanted to keep it with this project so that if I do have to make some tweaks, I actually know what's kind of going on, and I have a way to track that. You never know when one of these defaults might change or disappear, so at least now, you know, this is always going to be consistent. But if you don't want to install it, just go ahead and use that one there, but I'm going to use mine. Perfect. Now, what we're going to do here in today's program is we're going to continue by adding the actual OTA capabilities. There's a web page you can have a look at called Basic ESP32 Basic OTA Programming in Arduino IDE. There's a link to this in the description down at the bottom. I'm using this as my guide. It talks about some Python stuff, which I think I've already done. I'm actually not positive, but I think I have. And now we're actually just going to have a look at this upload our OTA routine serially and whatnot, just to see if it actually works. This is sort of just a test in order to get the OTA, to make sure that my Arduino IDE is actually set up and working correctly with the OTA. So if we open up File, Examples, where are we? Scroll up a little bit. So examples from the ESP32, we have Arduino OTA Basic. I'm just going to use this as a quick little test. So we have here star side, and the password to my network is, yeah, right, like I'm going to tell you. Fooled you. So, sorry. I have to take this off screen and do this little bit off screen, get it to compile and upload, and then I can go back. So just give me a second here. First things first, what we really need to do is I need to plug a cable. I need to plug a cable into the microcontroller. There we go. Now, okay, that's good, that's good. Okay, so now let's go back and finish this step off. Just give me 1 minute while I actually pull up that password. Where might that password be? It could be this one here. Indeed. So I'm going to take this off screen. Bye-bye. I'm going to actually hard code my password into this file, and then I'm going to go ahead and hit upload. We'll let it compile. There. So it's compiling. I've gotten rid of my password so you can't see what it is. You thought I was going to give you my network password. Okay, so this is compiling. Just because I want to put this sketch onto, hang on. What's going on here? Yeah, I want to change this first. Before it actually, I'm not going to let it upload. I want to change this. That has to be different. What does it have to be? I will show you what it has to be. If I go back here to my own data file, HardSense, I've already got my Wi-Fi device ID that I want to reuse called HardSenseESP. So host name HardSense. This way it shows up on my network the right way. Now, okay, good. So that's going to set the host name. It is important to have that set there. I don't need to change the port. I don't need that, not for now. This is not nothing. Okay, so I gotta put that password in there. Okay, so it did verify and compile properly. So good, I can ready to do the upload. I'm just gonna put the password in again. Where is it? There it is. Do a upload this time. There we go. So now it's doing a compile. It'll do an upload. We'll actually see over here down below me in a minute. I'll have to go probably push the button to upload this sketch. So it'll log in. It's going to set up the Arduino OTA object with my name, the proper name. Connecting. Okay, see it's connecting. Oh, look at that. It connected automatically. How's that for awesomeness? Okay, so there's actually a serial connection that we should be connecting to. So let's open up the serial monitor here. And then we'll reboot this. So yeah, it picked everything up. It's on the network. That seems to have worked. Ready IP address. So now it's looping on Arduino OTA handle. So now if we go look at that document, this one, yeah, it just, so basically now it says, now let's upload a new sketch. Hang on. Open the serial monitor, yeah. Remember, you need to add the code, yeah. Hang on, what are we missing here? Oh, there. Okay, yeah, we've done that. Basic OTA, yeah, we've done that. Now the following code should work, yeah. Go ahead, upload the sketch, yeah. So are you saying it should show up in here already? As a port? It does. Look at that. There it is. Crap, that was easy. How big was this program? Nope, that's not it. Where's the number I'm looking for? There it is, way at the very top. That is 73. So I wonder how big this is going to be when I add it in. Because all the Wi-Fi stuff is already in my application. So what I'm going to do... That was pretty cool. Okay, so good. Now let's actually do it. What do I need to do here? Okay, well let's do this. I'm going to actually just have this loop right here, some serial.print line. I'm going to, you know what? I'm going to do this even. to prove that this actually over-the-air update stuff is actually going to work, I've got my microcontroller here. There's my USB cable, unplugged. So now all we have is the power connection and the Wi-Fi. Good. So this next update, oh shit. No, this next update, I'm going to add code for the serial.print line, and then I'll plug it back in and turn the serial monitor on, and we should see that coming up on the serial monitor. Don't worry, uploaded by OTA. Good. Yeah. I don't want to do that. Whatever. I don't need to do that. What I do need to do is go to Tools, Port, select that one. Yeah, that's fine. I shouldn't need to worry about that. Now I need to put that password back in, and then compile this serial port. Yeah, that's fine. I don't need that. Did I close it? Where's the serial monitor? I closed it, right? Right. It closed by itself. That's right. That's why it's giving me that problem, because that actually uses the same, the serial monitor uses the same option here. So, right. That's why it's giving me this big error. So, yeah, definitely not a problem. This would normally have been on COM port 6 for the serial monitor, and I chose a new monitor, which, yeah, no, this makes perfect sense. Good. Now, the only reason why I'm actually using this line is I'm going to upload this firmware through OTA. When it reboots, then I'll just plug in the cable, which will put COM6 back into this list, which I can connect the serial monitor to, and I will see this text coming out on that serial monitor. But it won't be a firmware update or anything like that. It'll just prove that this was actually, the firmware was updated through OTA. So let's see, I've got HardSense selected there. I do upload. That's all I have to do, right? Sorry, you weren't looking at the right thing. I screwed up again. I was talking about what's going on over here. So I just added this line. And now I am doing a Tools Port HardSense. Now, I had the serial monitor open when I selected this. That's what caused a whole bunch of errors. Oh, look at this. So I'm getting this popping up. So private networks allow access. So that's the first time I've used this. So look at this uploading line here. Beautiful. Is it done? How do I know it's done? This is one big line. Is it done? It must be done. I seem to have control of this again. Okay. So, you can watch down below me, right here. I'm just going to plug the USB cable in so that I can connect the serial monitor. Where is that cable? There it is. How's my oscilloscope working? Hang on. I just did a bad thing here. Hang on. Sorry, I did something bad there. Okay, turn that off. We need to, okay, turn this on, plug this in. Okay. Now, what I'm going to do over here, back on this window, I'm going to go ahead and open the serial monitor. Nope, sorry, Tools, port 6 is back. So serial monitor. There's my serial monitor. Now when I restart the ESP32, I should see this uploaded by OTA line. Oh, I forgot to put the password in. Son of a bitch. See, password is empty. It's failing. That's why it's saying this. Connection failed, rebooting. Close this. So I screwed that up. Okay, so let's go back to normal. I'm on COM port 6. I need to put my password in here. Dumbass. Oops, not that one. You go away. Can't believe I forgot to do that. Okay, so I'm uploading the default code again without my little change to it. Stupid, I can't believe I did that. Come on now. Come on, hurry up. There we go. Okay, so let's open up the serial monitor. We'll restart this. Okay, so we can see it's just booting ready IP address, which is what we expect. Ready IP address, good, good, good. Okay, now tools, port. You can see it shows up in this port. So where's my serial monitor? I'm going to turn my serial monitor off. No, I keep hitting that button. So tools, port, HardSenseESP. Now back over to the device. Let's unplug this cable. So this next update will be over the air. It's got to be over the air. And I'm going to make a line in here. This is what I did before. Serial.println added via OTA firmware update. Now, I'll recompile this as firmware. It'll upload it over the air using this. Then, once it reboots, I can connect the cable to it, connect the serial monitor, and we'll see this line print out. This should work. But I gotta put the password in. Don't forget to put the password in. This is where things went bad last time. I didn't put the password in. So let's put my network password in. Let's do the upload. Okay, that's compiling. Okay, it's doing its thing. It's compiling. You can see that, right? Okay, good. It's not no USB connection. Over here in the Arduino ID, it's doing the compiling. The port selected is my HardSenseESP. That's this thing. It's connected to it. It's uploading a whole bunch of code. We can see this bar on the very bottom of the Arduino ID just going. Is that how you know when it's done? Okay, done uploading. There it said right there, done uploading. So that's it. I should be able to plug the serial cable or the USB cable back in, select COM port 6, which is the serial monitor, and I will now see that line being printed out on startup. All right, over here. Okay, back to this view. Tools, port 6. Open the serial monitor and restart it. Added via OTA firmware update. So that works. All that code works. We've just proved it. Good. Now what I got to do is add it to my project, and that's what shouldn't actually be too hard to do at all. Okay, so first thing we need to do, where is it? Where were we looking? So in the HardSenseESP, we're going to go ahead and I want all of this to happen on the Bluetooth configurator screen. That's my configuration screen. In that screen, the Wi-Fi isn't actually being used. Instead, the microcontroller is connected to the computer via a Bluetooth connection. But it doesn't have to be. That Bluetooth configurator screen is just sort of where I want all of the configuration and things to be done. Now, I got to go ahead and rebuild our HardSense and put it back onto the microcontroller because, as you can see, that's not working. We just did that whole proof of concept with the OTA, so that was awesome. So let's put HardSense back on there. And then I will show you the Bluetooth configurator screen and what we're going to do there. I'm actually going to add a new, basically a new button that we can when we boot up HardSense, we can go to the Bluetooth configurator screen, press this button, and that will activate the OTA updater. And then we can go ahead and connect to it and do the update. This should work. That's my theory. And I'm sticking to it. I don't need this anymore. Okay, but Visual VS Code with the Arduino plugin is slow as hell. It takes forever to actually compile. Finally there. Got to push the button just about every single time. There we go. Now we'll let the code update. The files should still be in place. I don't think they've been overwritten. So yeah, good. Everything's still connected. That's wonderful. Perfect. So in our Arduino code, you see we have our setup function. And then we get down into our big loop. In our loop, we just check to see, are we connected to something? Yes. If we're not, we go ahead and start a routine activation to see what might be going on. But if we are connected to something, we just go ahead and run this as proper. Basically, our loop here is running on core 0 of the ESP32. The display manager, on the other hand, the display handler, what's handling all of the beautiful little GUI updates, is this. That's running on the other core. So the ESP32 is a dual core microcontroller. And up here near the very top of setup, we're actually creating a whole new task called TFT core process. And this is where the display handler runs. It runs on its own little 250 megahertz processor dedicated to just updating the screen and checking for the touchscreen controller. And here it is. That's the entire process. Display handler.run. That's basically a while true loop. So once we get into the display handler.run, that just never exits. But that happens quite early in our setup process. We go ahead here, we just do some basic initializations to our serial object. Our serial object actually runs on our main loop counter. This is on core 1. So core 1 is essentially dedicated to validating some inputs from external sources, in this case the volume controller, and handling our output queue. So when we need to send data out, this is all done through our serial object, which runs on this particular core. Our Bluetooth configurator actually happens right at the very end of setup. We check to see if this button is pressed. This is called is Bluetooth button pressed. If we look over here on our actual device, that's what this button represents. This is my BT button. If this button is actually being pressed during the setup routine, or during our setup routine, it jumps into here and says, okay, we're going to go into our Bluetooth configurator screen, and it runs this function right here, handle Bluetooth connection. The serial objects handle Bluetooth connection. So if we go into our source directory, serial, we have our serial object, and we open that up, and we look for our what did I call it? Handle Bluetooth connection, right? Is that what I call it? Yeah. This is what we'll see. Once we end up in this routine, let's have a look at what we'll see. So I'm going to go ahead and restart HardSense by holding this button down, and we'll go into the config screen. Whoops, wasn't holding the button down. Sometimes my breadboard connections don't always work. You know how breadboards are. So this is, in fact, the Bluetooth configurator screen. Now, on this screen, the Wi-Fi chip is not turned on. It's actually not connected to the Wi-Fi network when we're viewing this screen. However, the Bluetooth radio is, in fact, engaged. We are, in fact, able to connect through Bluetooth by, if we look here, go to the Bluetooth. This is going to connect to the serial port over Bluetooth. So now we know we have a Bluetooth connection. But what I want to do is I'm going to add a new button right here in this big space. It's going to come all the way from the bottom of the time panel all the way down here, and this will be my over-the-air update engage button. So we're going to do something fun and fancy there. So this is the Bluetooth connection. You can see that I've connected successfully and scraped some information from it. We can exit that. And if we look at our code, this screen, this Bluetooth configurator screen, is built from our display handler GUI. We go into the GUI, and we have our Bluetooth configurator screen class. We just want to open up the CPP and the .h. So this is the file that constructs the screen we're looking at. Here's our, if we look at the constructor right here, whoops, right here, the first thing we do is we set up our theme object. There's a reason why we do this. And then we hit RTC begin. We have to include the RTC object because, as you can see, we're actually displaying the time and date on this screen, and it's coming from the RTC, so we have to have RTC begin. That's this code right here. Now I'm working through a bit of a bug here with the fonts. So here's what's kind of happening. This goes back to, I think, stream 1 of this particular HardSense project. The screen class, all of these screen objects, the Bluetooth configurator screen, the home screen, game screen, every screen that you're going to build, that I want to build with HardSense, they're all based on the HS screen base object. And inside that object, one of the things it has to do is get a handle to the SPIFFS operating system and load the fonts. All of the fonts are stored in these little files on the file system. This is how we get such beautiful fonts to be displayed on this little TFT. I mean, look at it. When it was running, those fonts look beautiful. Pardon me. Now, the display class is running on Core 0. When it's instantiated, its base class, right here, screen base. So when we create a new screen of our own class, it actually has to call, the base screen. And inside there, it takes care of some font work by opening up the file system. And that's how the class is able to switch between fonts, the 18-point, 14-point, and the 10-point fonts, depending on what I want to draw on that screen. However, the Bluetooth configurator screen, this screen, is actually created at the same time that we have our serial object accesses the SPIFFS file system. So our serial object is responsible for saving new data. If we have a look here, we can actually update these values, the SSID and password, the server names, and all of these, remotely from this application, right? Settings, Bluetooth configurator, connect. So we can go ahead and update those values just by sending in new data right here. So that serial object then writes that data back to the SPIFFS file system. And when it does that, it actually breaks the handle that the screen object has to those fonts, because its SPIFFS file handle is suddenly invalidated when the HS serial object opened up its new file handle, saved, and it does a save. If we have a look here, save settings to HFS. So this uses the file system object and writes the settings, and that invalidates the handle that the screen class has, and that's giving me a lot of trouble on this configurator screen. This is why you see these fonts up here are so weird, and it's going to get even weirder as we do other things, but dealing with that right now is a pain in the neck. So right now I want to create a new box for this, and we'll call it void, oh hang on, draw OTA panel. So this is the function that we'll use to actually draw our little panel, and we're going to make it a button too. That way I can touch it to activate the Arduino OTA functionality. I don't want it running all the time, right? Only when I actually want to do something. So draw OTA panel. Okay, basically I want to draw a box over there. Let's see here. Draw a device ID panel. Let's start with that. Okay, so let's go back to here. We need some new coordinates. That's what I need. This is called the OTA panel. That was not English. Stop that with your fat fingers. Come on. OTA. Over here. OTA. So I got my OTA panel X and Y. Let's take this. I don't know what's happening there. I gotta mess with that a bit. And we're gonna do this. We're gonna just take this and paste it here. I'm gonna change this to be my OTA panel. Oh, and I guess I gotta move my panel over. So the dimensions that I want this to be is this. My time panel starts at 207, so I want X to be 207. I want this box to be right underneath that panel. And the Y, let's see, where's my time panel? This is 52, so I want to put this one 52. There we go. Okay, OTA panel X, Y, width. I want to keep it the same width as that time panel, but I'm going to do it at a much different height. So the same width is 113. Height should be 124, 5, 6. I'm going to go with 127. I'm trying for height. I'm actually trying to get it to be all the way from the bottom of the time panel all the way down to here. I think that's about, should be 127, 128 pixels. Let's see here. Device IDs. I'm going to change this to OTA. Okay. Now, I'm going to go back to, let's say, my home screen, just as an example for what I need to do is this next step. I need to handle the touch. So I want to copy this code right here, GPU panel touched, and just see what's kind of going on here. Now you'll notice this is actually doing just a small little comparison for some global variables that are defined in here. Where is it? should have been defined. Oh, game screen. You stay open. And you stay open. No, not game screen. Home screen. That's why I couldn't find it. Home screen. CPP. Thank you. Stay open. Home screen H. Okay. So these are the values that actually define that click space. So I'm just going to copy these into my own configuration H for OTA panel. Take this text. There. Oops. Okay. Now I need a new function called, what did I call it? GPU panel, OTA panel. It's a void, isn't it? No, it's a bool. Oh yeah, it has to be a bool. That's right. That makes sense. And it's got to be, where is it? There we go. Okay, that makes sense. I'm just going to copy that, paste it over here, rename it. I think that's all I have to do there. Now, if I go to the home screen touched function, and I'll just take this, I'll just take the whole thing. Go to my Bluetooth configurator, paste it down here. Now, change the class definition. What did I call mine? OTA panel touched. And all of these are called OTA, right? Now, one of the things I'm going to be doing is a lot of refactoring, which is why one of the reasons why OTA update capabilities is going to be awesome. Like you can even see here the way I'm doing this, it can all be refactored. I was a one-man development team just trying to get these ideas out. So there's a lot of changes I can make to this that's going to shrink the compiler size and probably speed up a lot of the runtime code as well. And I'm really looking forward to that. But I want to get to making the circuit boards tomorrow. And do some circuit board work over the weekend. So we're just going to do this. Bluetooth OTA panel touched. Now we need to add a new function or a new call to that in our handle touch. So does our Bluetooth have a handle touch function already defined? No, I don't have a handle touch function here. Not a problem. What we'll do, go back to the home screen. Now this should be a public function, handle touch. And over here, handle touch. Go back to the home screen, take this handle touch. Didn't I already copy this? No, I didn't. And I want this function to be in my Bluetooth, but I actually want to place it up here. This is one of the core functions, and I like to have this there, sensor list. It usually goes right about there, right? Yeah, right after the sensor list, handle touch. So I don't need this. I don't need this. I just need an empty function call for now. And this is called OTA. Oops, hang on. OTA panel touch. Serial.println. Oh, you've touched me in my special, in my spot. You've touched me. Okay, we'll just go with that. Right. Okay, so good. But what we actually now need to do is connect that to our display manager because we don't have a way to call this yet. So let's go have a look at our Bluetooth functions file. I don't have an interface set up for that. So let's go into the home screen interface and just steal what we have there. Where is it? Home screen functions. On interval sensor list, here we go, on touch. We're just going to steal this function and put it into my Bluetooth functions. Right there, we're going to rename it to handle Bluetooth Configurator touch. We're going to call that object, and we're done there. Now in our, that should all be open, right? So let's just see, handle Bluetooth Configurator touch. Now in our display manager, right here, the display handler, we go into the load screen, load new screen, and you'll see somewhere in here we've defined our Bluetooth configurator screen. Now what we need to do is connect the handle touchpoint function to the update Bluetooth. Nope, not that one. This one. Handle. Yeah. So we're just taking that function pointer and pointing it at my interface. Save that. So the interface is our Bluetooth functions. This is the interface, which it's just a wrapper for the specialized object. We can't have those function pointers. They're just void function pointers pointing to this class specific because they don't mesh. And the compiler just say, no, I don't know how to take a void pointer and use it with this object pointer. And because these objects are always changing, here it's a Bluetooth configurator screen, here it's a home screen, then we have a game screen. So we use those interface functions just as a bit of a shortcut to allow that display manager to unplug in its functions and plug them in somewhere else as a bit of a shortcut. It makes life really easy. Why is my home screen unsaved? I shouldn't have to. There wasn't any changes to this. So that should take care of that. I should now have touch functionality defined. Oh, wait a minute. I don't think I actually defined those coordinates. So low X should be OTA panel X. And low Y should be OTA panel Y. High X is the width. Which is really 95? Where's my type panel? Show. That doesn't seem right. Where's my time panel? Bluetooth, draw time panel. 113 for width and 52. Okay, so let's see here. 113, so that's 210, 20, 320. And high Y is, what is this, 127 plus 52? Is 127, 129, 179, 180. Let's see that. That should work. You know what? There's a better way to do this, isn't there? Yeah, I'm just going to do this for now. Screw it. This will work. So this should draw me what this should do now. Right here. I'm going to put this in my up here. Update time. Draw time panel. I'm going to do that last. Draw my OTA panel. So that should now draw a new panel. So when we upload this code, compile it and upload it, this should draw me a new panel in this space right here. And it should also give it a touch capability. So when I touch that panel, it's going to cause some text to be written out to the serial monitor. That's just a stub so I know what's happening. Right, because I've got the OTA panel that returns true, and our handle, the handle touch function says if it was touched, just print some text out. Okay, good. So let's just go ahead and compile this and see the basis for our new Arduino OTA button. takes forever to compile this code. Come on now, compile some code. How's my oscilloscope doing over there? So still plucking away on just updating the screen once a second. That's good. Code is still compiling. I'm going to have a Halls because, well, I need one. Still compiling. There we go. Push the button. Now the code is uploading. And you can see that the display, everything's just gone low on the microcontroller. You can see that on the toy oscilloscope. Okay, so it should be rebooting. And we're up and running. Okay, now the real test, let's go to the Bluetooth configurator screen and see our new panel. There it is. Now, I'm going to go ahead and connect the serial monitor right there. So you can see the whole system's rebooted. Now I'm going to go back into Bluetooth. There's our Bluetooth configurator. Now keep an eye on the bottom of the screen here in the serial output. When I touch that box, this should print out some text. As long if I did my my touch handler correctly, it should say "You've touched me" somewhere down here. Look at that. It works. See? Fantastico. Now, we've also obviously messed up a little bit on the text. That's because I'm not loading any of the fonts anymore on this screen. I actually wanted to just use the default fonts. Because I'm hoping that's going to prevent a problem later on. Now let's go back. I want to get a close-up of this. So this is interesting. It's the time panel that's breaking everything. All right. And those updates. So I got to fix the text on these. That should not be using that particular font. For some reason it is. So in the code, I have an unload font here. And that's on update. Device ID. Yeah, text sprite unload font. So I just want those unload fonts to be back. Wi-Fi device ID. I shouldn't have to do that there because this is only called during the constructor, and I've already done this at the beginning of the constructor. So I'm going to switch these over to just a default font that doesn't use the font files. This way, when the Bluetooth configurator actually updates those, it's not causing any more problems. So now I need to do this here, update server port. Server name, server panel, yeah, sure. Password, yeah, that's already doing it. That's why you see it, we're already unloading the fonts here, and that should not be there. And the SSID. Okay, that should take care of that little bit, but now I do want to do something different with the fonts. I gotta close this. I think if I look in some of these examples, Let's see here. TFT-SPI 320 by 240. Some of these I think are just what are we doing here? Nope, not what I was looking for. I need to come back here. I'm just looking for a particular file I wanted to have a look at. I'll show you as soon as I find it. Nope, not there. Here. Libraries, TFT, there we go. What happened here? There. So this is the TFT-SPI header file. I'm just looking for some particular functions for fonts. FONT. Set font. Nope. Nope, that's not going to help me. Too many instances of that. Load font. No. What am I trying to... Where is that function? Init, push colors, draw, set, invert, set text size. That's what I was thinking of. Set text size. Now, I haven't actually had to do any of this because I've been using so many custom fonts lately. I literally couldn't remember what I was trying to do with these defaults. So set text size. That's the one I'm going to need, because what you can see is going to happen here. You see all the text here is definitely small. This is just the default whatever is being used for drawing that. So I need to change that without using the actual font files, because like I keep saying, the font files are being broken. So I need to go back to my right here. Sorry, I'm chewing on halls. It's because I'm still sick as a dog. What I want to do up here is TFT set text size. Is that just a number? Do I have to put in just a number there? That's what is there? Let's just see here. No, it doesn't say text size in here. I'm assuming that's just a number I stuck in there, right? A uint size. But is that like a 0 to 100, or is like a macro for small, medium, and large? Well, let's find out. Set text size to 12. Okay, I don't know. I seem to remember from a while ago that there's smaller numbers like this, but let's just find out what happens here. And I want to do a text printer spite text size. Oh, set text size. 12. So this one needs to be, set text size, okay. Let's make sure that's unloaded. Now the time panel is giving me a problem, so I'm going to have to do something there, but not yet. Let's just get this working, and then we can worry about the time panel later. What did, oh yeah. So you can see our oscilloscope is still keeping track of our CS switch on the SPI bus for the display. Every time it gets pulled down, that means that there's an update being sent to the display from the microcontroller. It's all coming off of this little red wire here, and you can see it's connected to the third pin from the bottom on the display. That is the CS pin, the chip select pin. We happen to have one right here. I don't know if you can actually see what that says or if that's just really blurry. Third pin from the bottom says CS. That's what it's connected to. You can see it a little more clearly here. It's this line right here. And that's connected to the oscilloscope. You know, it is just remarkable. Well, this, oh, hey, look at that, it's connected. You know, starting off with one of these Arduino Damula Nova microcontrollers, it still works. It's slow as hell to update, but it still works fine. But nowadays, we can even go to these, which are less than $10. And for capability's sake, I mean, this thing isn't even comparable. Wi-Fi, Bluetooth, dual-core 250 megahertz dual-core processor, file systems, over-the-air updates, a whole bunch of even 2 built-in, what are they, 10-bit or even 12-bit DACs, digital to analog converters, like true DACs, which is really cool. Actual analog outputs on 2 of the pins here. Less than $10. Now, an Arduino Uno costs more than that. This is pretty much, it's even cheaper than a Teensy, these things. But they don't have a SSD card on them. However, this does. No, wait a minute. The display does. The displays have an SSD card in them. Less than $10. This is pretty much a go-to chip for me now because there's so much lower. You know, I used to like to use the Arduino Pro Minis, both the 16 megahertz or the 8 megahertz, 3.3 volt. But think about that, 8 megahertz little Arduino Pro Mini with 12, 13 pins. Available pins, 13 available pins, and those things are expensive. They cost a lot more than this thing does, and this thing has way more pins and is a dual core 250 megahertz. You can often think this is serious overkill for a lot of projects, but really, if you're going to put this into a project, this is cheaper, it's going to be faster, and it's not overkill because it's just so much cheaper. Use these, awesome. No, I don't work for them or make money off of them. Let's go have a look at our Bluetooth configuration screen and see what those font sizes look like now. Are they huge fonts? Okay, so those font sizes are too big. Okay. Well, you learn something every day. So let's change this down to, I don't know, 3? Wow, that is some seriously big font. Okay, well, while that's compiling, you have a look at my oscilloscope, see what's kind of going on there. I'm going to go have a drink, just grab myself a drink because I'm thirsty. Oh, what did I break? All right, I'm back. So all we're trying to do right now is get the look of that Bluetooth configurator screen better with the right text size, and I'm adding my new Arduino or my new OTA panel so that when I want to do a firmware update, sweet, it automatically connected. When I want to do a firmware update, I can just open up the Bluetooth configurator screen, touch that panel, which will initiate the Bluetooth updates, and that'll be really cool. Now let's start this and see what those fonts look like. Still too big. What the hell? Did I not do that right? Oh, I didn't do that one. Shoot. Now it's going to take forever to do this again. Okay. Yeah, that should work because it's not being touched anywhere else. I shouldn't have to reset that font size or that text size. That should actually work everywhere. So that's going to be good. It takes so long to do these updates though that it just makes your whole development process last so much longer. That's where Visual Micro comes in as a plus. It speeds things up by a lot. Come on. Come on, you can build. Must build faster. Look at that old oscilloscope. Trudging away. Giving me updates. Feeding me info. That's data right there. Hey, uploading. Hey, and it connected automatically again. No, it did not. I have to push the button. Okay. Then we'll go into Bluetooth mode. Ready? 60, 73, 80%. Alright, push the button. So when it reboots, it'll boot right into Bluetooth mode. No, text is still way too big. Well, let's change that to wow, that's a 3? Okay, let's try 1. That's a 3? How big is this? Because, geez, how big is this font? Oh, you know what? Looks like I'm missing the bottom border in my OTA panel right there. So I have to fix that. That's okay. I just want to go into this one right here. Draw panel. Text sprinter, fast horizontal line at 2021. Those are the lines I want. Oh, I don't have my delete sprite line in here. That's bad. There's a memory leak right there. There, that's better. You gotta have a delete sprite in there, otherwise you're gonna have a memory leak. I don't need that. Text size though, text size 1. This better work. I'm gonna be sad if it doesn't work. Now it's connecting. We'll push the button when it's ready. $60, $70, $80. Push the button so when it reboots it'll just jump straight. You know what? I'm gonna cheat. There. I just changed the wiring so that it's just always going to go into Bluetooth mode now. There. I don't have to hold the button now. I just moved the wiring. So I just moved this wire from the button connector to the ground connector. So now it's always low. Look at how tiny that font is. So I guess I got to try font 2. Where's my constructor? Font 2. Okay, that was annoying. Is there like a negative font size or something? Well, if that's font size 1, font size 3 was bleeding giant. I'm unhappy about this. Oh, shoot. And I was going to move the OTA text over a little bit. You can see that that OTA text is kind of too far to the right. Let's move that over to the left a bit. 70, 60, 50. Let's move that to 45. That'll happen the next time I do an upload. It won't make it this time. Still upload or still compiling. We can see it taking its time down here. Wow. There we go. Push the button. Upload the code. Now I don't have to worry about pushing the button because, like I said, I've actually just changed the wiring so it goes directly to the ground now. So it'll just go straight into Bluetooth mode. See that? I don't, what the hell, eh? I'm just going to have to leave it at text size 1. This is something, I could come back and rebuild this screen and make it pretty later. Let's stop shaving the yak. I'm going to go back and put this to 1. And we're just going to go ahead and get the functionality built. Otherwise I'm going to be here forever with this. It just takes so long to actually build and do its thing. So let's just change this to 1 and be done with it. Now, we've got my Bluetooth handler button panel down here. No. And it has an action when touched. So if we take our OTA, basically what we need to do when it gets touched, we need to send a command back to the serial handler called enable OTA. We'll call it enable OTA. So we need to go to our serial interface, and we're going to add a new option here called config. Oh, almost forgot to do the button thing. Enable OTA equals 0x. What was my last one? 41. So I'm on to 42, which is a capital B. Oops. Yeah, I'm going to have to just deal with the tiny text for now. We can come back and make it pretty later on. So OTA is lining up. Everything is good. Good enough. Just to make sure I haven't actually screwed anything up. Just to make sure we haven't screwed anything up. Settings, Bluetooth configurator, connect. So I'm going to change this value to newness, and 1, 2, 3, 4. Now this should just update the text in this field and not crash anything. So I'm going to actually go ahead and set my button back. So if this thing crashes and it reboots, I'll know it because it'll end up on the home screen. So just update the server info. It doesn't seem to have worked. Why? Area. Let's just reconnect. Update server info. There we go. So that actually updated here, and it updated here, and it didn't crash. So that's exactly what I was going for. I'm going to put it back to where it was, ARI 4121. Do the update. And you can see that it did in fact update and didn't crash or do anything bad. So that's good. That seems to be fixed for the most part. So that's good. That's good. That works. Exit. Now what I need to do is I have this new key at config enable OTA. I'm going to go back to my serial handler. This is in this update settings. I need to go to the dispatch command, and I am going to add a new key action in here. Config update time. This one is called config enable OTA. I need a function. What should I call this function? Enable OTA. Where's my header file? Let's call this void enable OTA I don't need to pass it a val. So what am I doing here? Oh, I'm going to show you real quick. In that display handler, you know where I was typing out in our handle touch where it says this serial.print? I'm actually going to replace that with a little command that drops a command into our output queue. And hang on, is that going to work? Shit. No. I need to do this differently. That's not going to work. That's not going to work. I have to do this differently. Hey, hang on. I just realized I have to do that differently. Weird. Do I have to actually... Let's go back to the loop here. What am I doing here? HS serial handle input, do the volume encoder. We're just going to yield. If the output queue isn't empty, add the string to the output message. I need to talk back. So this is one of the challenges when you're dealing with the multi-threads, is that when I push it, here, I'm going to connect my, yeah, it's connected. If you look down here at the bottom of the screen, when I push on this button on my new panel, you see the text that gets printed out down here. You've touched me. That happens every time I touch this new panel that I've added. This is my OTA panel. If I zoom in on it. So every time I touch this area inside here, it's actually sending a command. So the action being taken is that this is actually happening all on core 0. The display manager and all of the screen activity happens on core 0. My serial object, this is actually running on core 1. So we got all the display action happening on core 0, all my serial activity happening on core 1. Now, what I want to happen is when I touch this box, I want it to turn on the Arduino OTA capability. But that actually lives inside the serial object, which lives on core 1. So I somehow have to send a command back from the display handler to the serial object and tell it to do this. Now, all of the queues that I set up so far, I've got one queue which is where we send data from the serial object to the display manager that tells it to load a new screen or update data. There's a queue, this queue, where we can actually put information into this queue, and then that gets read out. It gets read out to whatever's connected on the serial, whether it's Wi-Fi or Bluetooth. But I don't have a way of sending a command back to the serial object and tell it to take an action. All this does is it just puts some data onto the output queue so that it can be sent out. This is how we can actually communicate with the HardSense 64 server. We say, start streaming data or stop streaming data. That's where the sensor list comes in. If we look at our home screen, we see this add item to output queue. We're saying add all of this data to our output queue as a list of sensors, and this is sent back to this program, which is then parsed and handled properly. But I don't have a way of sending data back to the serial object. This sucks. What do I do here? Okay, so for now I'm going to cheat and I'm going to start easy. If I go to my serial header, I am going to have, I'm just going to create a new section down here to keep track of some OTA stuff I build. Alright, so for enable OTA, no, that ain't going to work. Shoot. I have to send a command back from the display manager on core 0 to the serial manager on core 1. And I don't have a queue that allows me to do that. Okay, well, tell you what we'll do instead. We'll just actually, okay, we'll plug that in later. So for now, where is my handle Bluetooth? Whoops, over here. Handle Bluetooth. So once all the Bluetooth stuff is set up, it does this. While true. Wait for Bluetooth connection, handle input, handle output. For now, I think I'm just going to go ahead and just force the enable OTA. Did I actually write that method yet? No. We'll come back later and figure out a way to connect it with a signal from the other thread. Right now we're just going to go ahead and enable it by default. So for the enable OTA, oh shit. That's why I needed to have the button there. Yeah. Here's why. Let me show you this example. So this is kind of this is the code that I'm just borrowing as an example. You see this Arduino? This is what has to run. Okay. That's a good point. I love working with multiple threads. It can be a little interesting at times. Now let's see here. I think that's a bit of a blocker. That's why I don't. That's why I want it to be activated only on a button press, because I can just handle all instead of See, if I press this button, I want that to enable OTA functionality, and I can hand full control over to that object. And I only want to do that at a certain when I want it to happen. Otherwise, I need this screen to be responsive to the Bluetooth options. Like if we look at this, so this Bluetooth screen really is all about the Bluetooth capabilities. And if we stick something about OTA in here, that just, we now have that OTA blocking, and that's bad. We can't have this function call blocking what's happening on the Bluetooth handle. Well, what if I actually put the what if I actually did put the Arduino OTA code and into the Bluetooth configurator screen itself and gave ownership to the screen? Then this could actually run on Core. That's an interesting idea. That's an interesting idea. Because that will actually block. That will block everything, but there is nothing else coming in here at that time, so that's fine. Because the only thing that's coming in on an interval is that, and that can be paused. Because when I do want the Arduino OTA running, I do want it to have ownership. So let's go ahead and actually stuff it into this class. Yeah. I think that's actually not even a bad idea. So we're going to go back here. Wait a minute. Okay. Before I do anything, I want to come back to my compiling. Where is it? Oh, my Arduino output. This is... Where are you? There it is. Sketch uses 138. Okay, so I want to keep this line. I want to know how big my code is going to get after I add the following updates. So where's my README? Where is my README? There it is. Nope, that's not it. Is it this one? Hardware, software, ESP32, README. So I'm just going to put that in there for now, just so I can keep track of what's happening. Now I'm going to add a bit of code, but it's going to add some program space, but that's okay. So my Bluetooth configurator, I need to add no, I don't need that. I need this. Okay, this should be interesting. Do I need all of that? Shoot. I really want this in the serial object. This has to live in the serial object. I just realized that this has to live in the serial object. I can't shortcut that by putting it into by giving this screen ownership. You know what I have to do? And you know what? That's actually not an entirely bad idea. Anyways, I need to add a new queue. I need a new queue, and it's going to be a small queue. It's not going to get used very often, but I do need a new queue, and it's going to be called the command queue. don't need a mutex on it yet, but I'm going to need one later. For now, you know what I want to do? Wow, that just gave me a big idea. That's why I'm so quiet now all of a sudden. I just suddenly had a really big idea. It's a really good idea too, because it's going to actually open up some whole new flexibility for me that I even wasn't thinking of until just now. But it's worth doing this now, which means I might have to work late tonight, because I'm not going to be able to do this in the time I have for this stream left. Shoot. I just had this idea. Yeah, okay, I'm going to need that for my other project anyways as well, so I'm going to have to add a new queue object to this HardSense. That's cool. Add item to command queue. See, command queue. I don't need these yet. I'm just gonna get rid of these. Output queue. So command queue. Where is that? I'm just going to try something real quick. I meant to do this before, but I never did. I don't know if this is actually going to work. Whoops. I really don't know if this is going to work or not. If it does, this is going to be some refactoring I'm going to have to do later on. Where am I? Source queue item. Global definitions. Yeah, I don't need this. I just need this. Right? Let me just check. Yeah. Well, let's just see if this worked. Well, so I meant to do this before. My goal was to actually make these static functions so that I don't have to pass these around as a function pointer anymore. I think that'll work better. So what I'm doing now is actually sort of just a test to see if this will actually work the way I think it should work. Because now if I go to here, go to my handle touchscreen, add item to command queue, key. I need a key on here. I'm going to just do this for now, and then a string. That's just for an example. So that actually should work. So that's one of the things I was going to refactor, was that method for those other queues. Cool. That's a big change, but a good change. Hey, it did work. Nice. So what I want to do now is I'm going to set up this command queue, and this is a way to send, for the display manager to send commands back to the serial object. The display manager runs on core 0, the serial manager runs on core 1. And I need a way for the for the display manager, in this case the configurator screen, to be able to send a command back to that serial object and say, okay, start up the OTA capabilities. Oh. Yeah, that's what I thought. Oh, hang on. Yeah, that's not going to work, is it? So, when that panel is touched, I want to be able to send a command back here to the serial manager, and then the serial manager, which owns the Wi-Fi and the Bluetooth handles, this can actually start up the Arduino over the OTA capability, and this can run on the proper core. I just need a way to handle that. So what I can do here is in the okay, here's the loop, the handle output. So somewhere around here, I'm going to add the check for that queue, for the command queue to take the action. I should probably do that before the output, handling the output. Should handle commands and then the output. Hey, so it worked. That's good. Anyways, once again, I took longer than I thought. I'm still learning how to do these streams, so I'm hoping to get faster and not waste so much time anymore. But I do have to go now. It's been my 2 hours. So thank you for watching. Don't forget to check below PayPal me and Patreon accounts. Maybe shoot me a few bucks, help me out, buy some cameras, get a visual micro license, pay my rent, eat some food. I really appreciate you watching. I really thought I was going to do more, but I'm definitely going to get some of this work done later. And look for a stream this weekend about making the circuit boards for this. That's going to be a lot of fun. Anyway, so thanks for watching this particular stream of my HardSense development, starting to add the OTA capabilities. We know it works. That was a lot of fun. I liked seeing it show up in here, this HardSenseESP, as a port. Boy, that's cool. Over-the-air updates. That's going to be awesome. Just have to do some neat work. I'm going to do some refactoring here as well soon. I might even come back for another stream of just doing that. It is 6:30. We'll see what happens. But anyways, thanks again for watching. I appreciate your time and your donations and everything like that. Anyways, enjoy your evening. Bye.
Shut up and sit down.